Today we are going to look at understanding the coordinate plane and graphing points on a coordinate plane, also known as a coordinate grid. So what we are going to look at today is the different pieces and parts of a coordinate grid so that when we communicate about what is on the grid, we can all understand which parts we're talking about. So we have a vertical line, which is called a vertical axis, and we have a horizontal axis. This is the x-axis, and this is the y-axis. So you will need to know which one is which in order to graph things appropriately on here. So what also we need to know is that this is always 0, where the x and the y-axis meet. It is also known as the origin. Make that note here. And I'll also label for you axis and y-axis. And each line represents a value. So this is 1 on the x-axis, and this is 1 on the y-axis. And where they intersect is also considered 1, 1. So when I write an ordered pair, I write them in parentheses. And which one is first is always the x, and the second one is always y. Not easily confused when they're both the same number here. And then we also use a capital letter to represent that point. And that could be like saying this is A, and we would label that point. So another ordered pair would be like 4, 3. Let's say that's B. So you would go over on the x-axis first, because that one is the x-axis, 1, 2, 3, 4, and then you would go up the y-axis, 3, 1, 2, 3, and make a point right at the intersection and label it B. So that's graphing on a coordinate grid and all the parts of a coordinate grid that you need to know for 5th grade. So let's look at this in a story problem situation. So the coordinate plane shows the layout of a state fair, kind of like a map. Use the order pairs to identify the locations of different events. So it looks like we need to figure out where face painting is and the snack stand is. So the face painting, the x coordinate is where? So find face painting. So how many times over is the face painting? So the x should be 2. Then how many up the y-axis is face painting? You can see it intersects with the 3. So then the ordered pair with parentheses and a comma separating them, 2, 3. Now the snack stand, what would that be? What would that ordered pair be? It's over 4, up 1. So the x is 4, the y is 1, so our ordered pair is 4, 1. Now we cannot switch them. If we said 1, 4 is the ordered pair, that would put me up here, over 1, up 4. So not the same. We have to make sure we use the x-axis first. X comes before y, remember. So the other thing we can do with a coordinate grid in our ordered pairs is talk about how they are the distance from one another and how to travel from one point to another. So this question is, how many units would it take to get from the ring toss to the book sale? So if we find the ring toss and then we find the book sale, if we traveled along the coordinate grid, we have lots of options here, but the distance would still be the same. So if I went over 1 and up 1, that's still 2 units. If I went up 1 and over, that's still 2 units because of the 1, 2 moves in between each coordinate that I had to get there. So it would be 2 units. Units being our label here. How far right is the snack stand from the origin? So remembering the origin is our 0. So how far right? So we're just going to move to the right 1 all the way until snack stand, 2, 3, 4. So it's 4 units right. Couldn't really see those. There you go. what axis does face painting and the book sale have in common? So is it the axis, our two options are X, or is it Y? So what do they have in common? Face painting and the book sale. Okay, so face painting and book sale are both on which axis? Well, they are not lined up with the Y, right? They're 3. They're not both on 3 because this one's on 2. But they are both on the 2 for the x-axis. Okay? Then practicing plotting, we're going to plot a point at 0, 5 and label it with the letter M for magic show. So 0, 5, so it means I don't go up at all. I am just simply going up that y-axis then. I mean, I don't go over at all, so because my x-axis is 0. And so I label that M. Okay? Now we're going to look at the different aspects about relationships and patterns that we can use when we are going to represent that on a coordinate grid. So looking at this story problem, we have the scouts are making model vehicles. They have a choice to make a model plane or a model boat. So the planes cost $2 and the boats cost $4. So we're going to make some ordered pairs to compare the cost with how many boats or how many planes that we could purchase and what that relationship would be with one another. So if I bought none, no planes, no boats, it would cost $0. So our order pair, of course, is 0, 0. A lot of times, be careful when we are looking at the corresponding terms in the patterns, they're often having to start at 0. So what if we bought one plane, one boat? Remember, the cost of one was $2 and $4. So the ordered pair would be 2, 4. Okay? And then what if we bought 2 planes? Then we would have times 2, right? So I would have 2 and 2 planes, that would make it 4. If I had 2 boats, that would be 4 and 4, so that would be 8. Our ordered pair is now 4, 8. So we're going to continue this as if we bought 3 and if we bought 4. So as you can see, we are starting this rule, this pattern, and we can see that we are going to have 6 and then 8 if we continue that. And then same with this one, we would have 12 and then 16. Making those ordered pairs as well to show the relationship between the cost of the planes and cost of the boats. So let's reflect on this for a second. What was the plane's rule? Now, rules will always go within the X or within the Y. And a rule has to work every single time. It has to be the same exact one, that no matter where you've started. If I would have started at 20 planes and 20 boats, the rule should still work. So what's happening with the plane? It looks like in some cases that the plane is being multiplied by 2. Okay, because 2 times 2 is 4. But if I go down here to the cost of 2 planes, if I were to multiply this by 2, that's not going to be 6. So that does not work as our rule. It has to work every single time. So instead of multiplying by 2, what could it be? It would be adding 2 each time. So when we write down the rule, we always put what operation's happening and then what number is happening with the operation. So this is a +2 rule. Now what about the boats? So the boats go from 0 to 4 to 8. Now remember, it has to stay the same. This is the same situation where it looks like 4 times 2 equals 8, but 8 times 2 does not equal 12. So we cannot use multiplying by 2 here. So what would the rule be for the boats? It would be adding 4. So you would put a +4. You could also write the word add as well. Now, the other aspect we have when we're looking at these is a corresponding terms relationship. So we have the pattern or the rule that goes down, and then what are we going to look at for the corresponding terms relationship? So what we'll look at is a cross. When we say corresponding terms, these are X and our Y, they're corresponding. So what is this relationship from one to the other? Patterns or rule going down, corresponding terms connecting from one another. So how do the corresponding terms compare? So for each term in boat is 2 times as much as the plane. Now be careful of which way you're going. We need to say the plane and we need to say the boat, and that relationship is kind of like the rule of what operation and what number's happening. So if I start with the plane, you could say times 2 equals the boat. Now this is a little elementary of how we could say this. Another way that might even sound more fluid, more smooth in saying is the boat is 2 times the plane. So that often sounds funny though too, because you're working backwards. The boat is means equal 2 times the plane. So it's equaling that, kind of like when we did expressions and had to think about that backwards. But that 2 times is the important aspect. If I were to rearrange this, the boat is not 2 times, or the plane is not 2 times the plane, the boat. Excuse me, the boat. So just because you have times 2, which one you put where does in fact matter. So now what we're going to do is we're going to model it on our coordinate grids using our ordered pairs. Go ahead and you can graph your ordered pairs right now, especially if you've printed off this paper. If not, this would be challenging to do on a loose leaf piece of paper. So what I would encourage you to do is think about which way would you move and what would this graph end up looking like using these ordered pairs. So I graphed my origin, my 0, 0, and then when it comes to doing my 2, 4 ordered pair, I go over 2, up 4, then I go over 4, up to 8, over 6, up to 12, over 8, up to 16. I use my pencil to kind of guide me of where I'm going. And because of these patterns or the rule or the relationship, you can see that it is a consistent distance between one another, and we could keep seeing how that price would change and relate to one another. So we're going to continue seeing story problems, having to continue the pattern and find how the corresponding terms relate, as well as graphing these ordered pairs. All right, let's get started.